K is same constant as 8.9875 times 10 to the 9th. And that's, of course, in MKS units. So we took a look at the total force here. What do we have? Total force, we've got, I'm gonna do this roughly. So 9 times 10 to the 9, that's what that gives me. This gives me 3 times 10 to the minus 6. I've got 10 times 10 to the minus 6. This is 5 times 10 to the minus 3 squared, so it's 5 times 10 to the minus 3 twice. And I'm just doing this because I'm doing this work in my head. The minus 3, the minus 3, and the minus 6 go away. And I've got 25 on the bottom, and the 10 to the 9 and the 10 to the minus 6 go away and give me 10 to the 3. So I've got 9 times 3, which is 27. I got 270 times 10 to the 3. All over 25. And again, I'm doing this roughly, but 270 divided by 25, well, 250 divided by 25 would be 10. So this is 10, and this is 10.8. Just those two. 10.8 times 10 to the 3. And that would be in units of newtons because it's a force. Now, the amount of work done to move that from there to there. Well, we look at the force that exists, and that means there's this force of 10.8 times 10 to the 3rd newtons trying to push that way. If this one's held in place, that one's trying to go that way. That's what the force is doing to it. And so if we take it, we've got that force, 10.8 times 10 to the 3, and our initial location is 5 millimeters, and we bring it to 1 millimeter, we can look at that and determine how much work is done. 10.8, I've got a 10 to the 3 here, that is a 5 minus 1 is 4, that's 4 times 10 to the minus 3, and I end up with 4 times 10.8, which is 43.2, and this would be energy in joules, or work done in joules. Okay. And what we're really, since we're talking about this one, we said it had a 3 microcoulomb charge, but what if it was just a test charge or whatever? Really, what we're talking about is this Fe. If you remember, I talked about the fact that there's something called an electric field, which is Q times E. So whatever this Q is, if you can calculate the E, then that allows you to calculate Fe. So you could have a charge here, you say, well, what if this was a 1 micron charge? Well, that would just be 1 instead of 3 here. Divide that by 3, what was going on. So if you have either the electric field given to you, or if you have the information I gave you here, you can calculate that and get that. So that's an energy, it's joules, just like joules that we calculated before. It's just now it's an electrical energy as opposed to being